Hi class, so today we are going to be talking about how we can use limits to find the slope of a tangent. So in advanced functions, we had to use estimations to find the slope of a tangent by creating secants that became closer and closer to the tangent. So the investigation you're doing is going to be using this knowledge and hopefully leading you towards the understanding of how limits can be used instead, and then to find an exact answer, which is obviously preferable. So first, again, just to refresh the concept here, here we have a cubic function, a downward facing cubic, and we are referring to this point x here. So we want to use the red secant line to estimate the blue tangent line. Now, as you can see right now, the slope of the tangent is just over 12, and the slope of the secant is about 4.5, just above that. So we have here a slider for the x value, but I've kept it there, and h refers to how far apart this second coordinate is from the coordinate that we want to estimate the tangent at. So as we slide h to become smaller and smaller, you can see that the secant approximates the tangent. So the secant comes closer and closer to being the slope of the tangent. So we can slide it all the way, and you can see the slope is changing to become closer and closer until it's right on top. So that is the idea of the secant sliding closer and closer. So I have given you the slope of a tangent investigation to do, and I'm going to show you a way to make it a little bit easier. So you can actually go on to GeoGebra. In this case, it actually is better than Desmos. Don't tell Mr. Filler. Because there's actually some more things you can do here that will be useful for you. Just has to open up here. Okay. So just create your function. So in this question, you're using the function f at x equals x squared. And you're going to be using estimations of secants to find the slope of the tangent at x equals 3. So you can actually do that by putting in the command line, and then we can do a point to a point. So you'll notice that the Q1 is at the x value of 3.5. So we want to create a line from, okay, so you have to start the brackets like this, and now start a new set of brackets for the coordinate. So the coordinate is at 3, comma, f at 3. So there's the first coordinate. Okay, and then you put a new set of brackets, 3.5, comma, f at 3.5. So notice here, not only does it draw the secant for you, but it also gives you the equation of that secant, and so you can see clearly that the slope is 6.5. So now you can actually just use GeoGebra to figure out the rest of this for you, so you don't have to use your calculator. Yay! So for Q2, you can just let this be 3.1. Sorry, just a second. Okay, and this be 3.1. Okay, and so there you can see that the slope is 6.1. So you can actually do all of part 1 in your investigation using GeoGebra instead of your calculator if you want to save time. Okay, so stop the video and actually do that now. Like, actually do it. Don't just copy what I'm going to show you, which probably most of you will do, but whatever. Okay, so here you go. So this is what you should have gotten for all of your slopes. Okay, so it's right there, so you can pause the video and check. So clearly we can estimate that the slope of the tangent at 0.39 is 6 because the limit, as x is getting closer and closer to 3 from either side, notice that the slope is getting closer and closer to 6 from either side. So we can say the slope of the tangent is 6. So it says graph it on graph paper and show them, but we did it on GeoGebra, so that's okay. So you found the slope of the tangent by finding the limiting value of the slopes of a sequence of secants. Since we are interested in points Q that are close to 3,9 on the parabola x squared, it is convenient to write Q as 3 plus h at 3 plus h all squared, where h is a very small non-zero number. The variable h determines the position of q on the parabola. So basically how big you make h determines how far away q is from p. As q slides along towards p, we make the values successively closer to 0. So in other words, we're doing a limit. We're saying that h approaches 0, so we use that notation. Okay, so if you go back to GeoGebra for a second, you can actually tell GeoGebra to write a tangent at 3 on the function f. So you can see there that that's drawn and its slope is 6. Okay, so part 2, again, I'd like you to pause and try it yourself. So actually find this limit. So then you can see what you're supposed to find there. When you actually go through and calculate the slope, you actually get h plus 6. Sorry, so you're not doing a limit yet. In the second part, you're doing a limit. So explain how you could predict it. Well, now you can let h be 0. So there you go. Okay, so the slope of the tangent is the limit as h approaches 0 of this function, basically the slope function, where our first point is q with an h value that is approaching 0, and our second point is the value we want, the coordinate 3, 9. So hopefully you guys understand that investigation and you know what you're supposed to get out of it. So now you should watch the video with the actual note and fill that out. Oh, sorry, I'm getting a call. I think they're calling me back to my planet. Thanks for watching. Hope you learned lots.